Welcome to the AI Research Roundup. I am Alex, and today we're looking at a paper from the Papers with Code Trending list, published on the 11th of June, 2025. This paper introduces a new method that achieves an incredible 112 times faster inference speed compared to standard diffusion models. The paper is titled, Marrying Autoregressive Transformer and Diffusion with Multi-Reference Autoregression. Alright, so this paper introduces a new image generation model called TransDiff. It works by combining two major AI techniques, autoregressive transformers, which are models that build up an image piece by piece, and diffusion models. On the ImageNet benchmark, this new model significantly outperforms previous methods. It achieves a Fréchet inception distance, or FID, of 1.61. The Fréchet inception distance is a score that measures how realistic the generated images are, and lower is better. It also gets a very high inception score of 293.4, which measures image quality and diversity. And as we'll see, the authors push this even further with a new technique. And for those who want to dive deeper into this work, the authors have made it very easy. They've released the official PyTorch implementation on GitHub. The repository has everything you'd hope for: pre-trained ImageNet models, a demo notebook to get you started, and of course, all the scripts for training and evaluation, if you want to reproduce these impressive results. Okay, so let's look at some examples from the model. At the top here, we see a gallery of images generated by TransDiff, a really detailed husky, a colorful duck, a bright flower. They're incredibly sharp, which really shows off those high-performance scores I mentioned. The middle section highlights an interesting aspect, how increasing the diversity of what the paper calls semantic features, which are essentially the core concepts the model has learned, improves the final image quality. You can see the car and tiger getting progressively clearer, but the most impressive part is at the bottom, showing semantic feature fusion, where the model takes concepts from two different classes, like a husky and a duck, and blends them into a single coherent image of a husky drake. This is a fantastic demonstration of the model's deep conceptual understanding. So how does the model pull off those impressive feats like semantic fusion? This figure gets to the heart of the method by comparing different image generation strategies. On the left, you have a standard approach called token-level autoregression, where the model builds an image one small patch at a time in a sequence. The middle shows scale-level autoregression, which progressively refines the image from a low resolution to a high resolution, but the key innovation is on the right. Multi-reference autoregression. This new method allows the model to refer to multiple, diverse, high-quality images at each step, giving it a much richer context to draw from. This multi-reference capability is what enables that powerful blending of concepts and high-quality output. Alright, so building on that idea of multi-reference autoregression, this figure gives us a more technical look under the hood. On the left and right, we see the standard approaches, a typical autoregressive model that builds images sequentially, and a standard diffusion model, which is powerful but very slow. The key innovation is the TransDiff approach in the center. It uses an autoregressive transformer to first generate high-level semantic features, which are essentially the core concepts of an image. These concepts are then fed into a diffusion decoder, a specialized component that translates those ideas into a final, detailed image. Alright, and here we see the hard numbers that prove how effective this hybrid TransDiff architecture is. This table compares it against other leading models, both pure diffusion and pure autoregressive, on the ImageNet benchmark. We're looking at those same key metrics, the Fréchet inception distance, where lower is better, and the inception score. And the standout result is right there at the bottom. The TransDiff model with multi-reference autoregression achieves a Fréchet inception distance of 1.49. That's the best score in the table, beating all the others and setting a new state-of-the-art. And while that top score is fantastic, this table really gets into the efficiency of the TransDiff model. The key thing to notice here is the one-step inference capability. That's the ability to generate a full image in a single pass. If you look at the baseline MARL model, it's completely unusable in one step. But the TransDiff model, in a single step, achieves a Fréchet inception distance of 1.69, which is already better than the baseline model's 256-step result. This just underscores how powerful that diffusion decoder is. It delivers state-of-the-art quality at incredible speed. Okay, and this table really puts that performance into a broader context, comparing TransDiff against a whole zoo of other model types, including GANs, pure diffusion models, and standard autoregressive models. A key column here is the one labeled with CFG, which stands for Classifier-Free Guidance. Classifier-free guidance is a popular technique that helps steer the image generation process to produce higher quality results that better match the target class, and it's where we see the best performance. Looking at all these models, the TransDiff H model, with our new multi-reference autoregression method, achieves a fresh 8 inception distance of just 1.42. This is the best result on the entire table, establishing a new state-of-the-art for this benchmark. Okay, so we've seen the impressive numbers, but this figure really shows the creative power behind those scores. What we're looking at here is called semantic feature fusion. This is where the model takes the core concepts, the semantic features, from two completely different images and blends them together. For example, it combines the features of a macaw and a tiger to create a new bird with tiger stripes. It even fuses a snail and a car to make a snail car with wheels. These results show the model isn't just mixing pixels, but truly understanding and combining the underlying ideas in a sophisticated way. From those incredible semantic fusions to the raw performance numbers, it's clear the TransDiff model is a major step forward. By successfully marrying autoregressive and diffusion models, the researchers have achieved a new state-of-the-art, not just in image quality, but also in unprecedented single-step generation speed. This work really pushes the envelope for what's possible in efficient, high-fidelity generative AI. That's all for this episode of the AI Research Roundup. Thanks for listening, and I'll see you next time. I'm Alex.